Probability. Introduction. We use the following words to express the possibilities in our daily conversation: impossible, sure, maybe, nearly, probable, 50-50. In everyday life, we come across statements such as, "It is impossible to defeat Indian cricket team in the next match. I will surely get distinction. It will probably rain today. There is a 50-50 chance of India winning a toss in today's match. Chances are high that the prices of petrol will go up. Most probably, Ria will stand first in the annual examination." The words probably, chances, most probably, etc. used in the given statements involve an element of uncertainty. For example, probably rain will mean it may rain or may not rain today. We are predicting rain today based on our past experience when it rained under similar conditions. Similar predictions are also made in other cases. The uncertainty of probably, etc. can be measured numerically by means of probability in many cases. Though probability started with gambling, it has been used extensively in the fields of physical science, commerce, biological science, medical science, weather forecasting, etc. Random experiment. Tossing a coin, throwing a die, picking a card from a set of cards bearing numbers from 1 to 50, picking a card from a pack of well-shuffled playing cards, etc. In the given experiments in which all possible results are known in advance, but none of them can be predicted with certainty, and there is equal possibility for each result, is known as random experiment. Outcome. Result of a random experiment is known as an outcome. Example 1. In a random experiment of tossing a coin, there are only two outcomes: head H or tail T. 2. In a random experiment of throwing a die, there are 6 outcomes according to the number of dots on the 6 faces of the die: 1 or 2 or 3 or 4 or 5 or 6. 3. In a random experiment of picking a card bearing numbers from 1 to 50, there are 50 outcomes. 4. A card is drawn randomly from a pack of well-shuffled playing cards. There are 52 cards in a pack as shown in the given chart. In a pack of playing cards, there are 4 sets, namely heart, diamond, club and spade. In each, there are 13 cards as king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 and ace. King, queen and jack are known as face cards. In each pack of cards, there are 4 cards of king, 4 cards of queen and 4 cards of jack. Thus, total face cards are 12. Equally likely outcomes. If a die is thrown, any of the numbers from 1, 2, 3, 4, 5, 6 may appear on the upper face. It means that each number is equally likely to occur. However, if a die is so formed that a particular face come up most often, then that die is biased. In this case, the outcomes are not likely to occur equally. Here we assume that objects used for random experiments are fair or unbiased. A given number of outcomes are said to be equally likely if none of them occurs in preference to others. For example, if a coin is tossed, possibility of getting head or tail are equal. A die having numbers from 1 to 6 on its different faces is thrown. Here, all the outcomes are equally likely. Example: how many possibilities are there in each of the following? 1. Vanitha knows the following sites in Maharashtra. She's planning to visit one of them in her summer vacation. Ajinta, Mahabaleshwar, Lonar Sarovar, Tadoba Wildlife Sanctuary, Amboli, Raigad, Matheran, Anandvan. Answer: Vanitha can visit any of the 8 places in Maharashtra, so she has 8 possibilities. 2. Any day of a week is to be selected randomly. Answer: there are 7 days in a week. Therefore, there are 7 possibilities of selecting any one day randomly. 3. Select one card from the pack of 52 cards. Answer: there are 52 cards. Therefore, there are 52 possibilities of selecting one card. 4. One number from 10 to 20 is written on each card. Select one card randomly. Answer: there are 11 numbers from 10 to 20 written on the cards. Therefore, there are 11 possibilities of selecting one card randomly. Sample space. The set of all possible outcomes of a random experiment is called the sample space. It is denoted by S or omega, a Greek letter omega. Each element of sample space is called a sample point. The number of elements in the set S is denoted by n of S. If n of S is finite, then the sample space is said to be a finite sample space. Following are some examples of finite sample spaces. One. For each of the following experiments, write sample space S and number of sample points n of S. 1. One coin and one die are thrown simultaneously. 2. Two-digit numbers are formed using digits 2, 3 and 5 without repeating a digit. Answer: 1. The sample space for coin S is equal to HT, therefore number of sample space is equal to 2. The sample space for die S is equal to 1, 2, 3, 4, 5, 6. Therefore, number of sample space is equal to 6. Therefore, if a coin is tossed and a die is thrown simultaneously, then the sample space is as follows. Therefore, number of sample space is equal to 12. 2. Two-digit numbers are formed using digits 2, 3 and 5. Therefore, sample space is equal to 23, 25, 32, 35, 52, 53. Therefore, n of S is equal to 6. 2. The arrow is rotated and it stops randomly on the disc. Find out on which color it may stop. Answer: there are 6 colors on the disc. The arrow can stop on any of the colors. Therefore, sample space is equal to red, orange, yellow, green, blue, purple. Therefore, number of sample space is equal to 6. 3. In the month of March 2019, find the days on which the date is a multiple of 5. See the given page of the calendar. Answer: multiples of 5 are dates 5, 10, 15, 20, 25, 30. Therefore, sample space is equal to Tuesday, Sunday, Friday, Wednesday, Monday, Saturday. Therefore, number of sample space is equal to 6. Event. The outcomes satisfying particular condition are called favorable outcomes. A set of favorable outcomes of a given sample space is an event. Event is a subset of the sample space. Events are generally denoted by capital letters A, B, C, D, etc. For example, if two coins are tossed and A is the event of getting at least one tail, then the favorable outcomes are as follows. A is equal to TT, TH, HT. The number of elements in the event A is denoted by N of A. Here, N of A is equal to 3. Example. Write sample space S and number of sample point N of S for each of the following experiments. Also write events A, B, C in the set form and write N of A, N of B, N of C. 1. One dice is rolled. Event A, even number on the upper face. Event B, odd number on the upper face. Event C, prime number on the upper face. Solution. One dice is rolled. Therefore, the sample space S is equal to 1, 2, 3, 4, 5, 6. Therefore, N of S is equal to 6. For event A, even number on the upper face, therefore, A is equal to 2, 4, 6. Therefore, N of A is equal to 3. For event B, odd number on the upper face, therefore, B is equal to 1, 3, 5. Therefore, N of B is equal to 3. For event C, prime number on the upper face, therefore, C is equal to 2, 3, 5. Therefore, N of C is equal to 3. 2. Two dice are rolled simultaneously. Event A, the sum of the digits on the upper faces is a multiple of 6. Event B, the sum of the digits on the upper faces is minimum 10. Event C, the same digit on both the upper faces. Solution. Two dice are rolled simultaneously. Therefore, the sample space is as follows. Therefore, N of S is equal to 36. For event A, the sum of the digits on the upper faces is a multiple of 6. Therefore, A is equal to 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6, 6. Therefore, N of A is equal to 6. For event B, the sum of the digits on the upper faces is minimum 10. Therefore, B is equal to 4, 6, 5, 5, 5, 6, 6, 4, 6, 5, 6, 6. Therefore, N of B is equal to 6. For event C, the same digit on both the upper faces. Therefore, C is equal to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Therefore, N of C is equal to 6. 3. Three coins are tossed simultaneously. Condition for event A to get at least 2 heads. Condition for event B to get no head. Condition for event C to get head on the second coin. Solution. 3 coins are tossed simultaneously. Therefore, the sample space is as follows. Therefore, N of S is equal to 8. For event A, to get at least 2 heads, therefore A is equal to HHH, HHT, HTH, THH. Therefore, N of A is equal to 4. For event B, to get no head, therefore B is equal to TTT. Therefore, N of B is equal to 1. For event C, to get head on the second coin, therefore C is equal to HHH, HHT, THH, THT. Therefore, N of C is equal to 4. 4. From 3 men and 2 women, environment committee of 2 persons is to be formed. Condition for event A, there must be at least one woman member. Condition for event B, one man, one woman committee to be formed. Condition for event C, there should not be a woman member. Solution, there are 3 men, M1, M2, M3 and 2 women, W1, W2. A committee of 2 is to be formed. Therefore, the sample space is as follows. Therefore, N of S is equal to 10. Now, condition for event A, there must be at least one woman member. Therefore, A is equal to M1, W1, M1, W2, M2, W1, M2, W2, M3, W1, M3, W2, W1, W2. Therefore, N of A is equal to 7. Condition for event B, one man, one woman committee to be formed. Therefore, B is equal to M1, W1, M1, W2, M2, W1, M2, W2, M3, W1, M3, W2. Therefore, N of B is equal to 6. Condition for event C, there should not be a woman member. Therefore, C is equal to M1, M2, M1, M3, M2, M3. Therefore, N of C is equal to 3. Let us take an example. A bag contains 4 balls of the same size. 3 of them are red and the 4th is green. You are supposed to pick one ball at random without seeing it. Then obviously, possibility of getting a red ball is more. In mathematical language, when possibility of an expected event is expressed in number, it is called probability. It is expressed as a fraction or percentage using the following formula. For a random experiment, if sample space is S and A is an expected event, then probability of A is P of A. It is given by following formula. Probability of A is equal to number of sample points in event A upon number of sample points in sample spaces is equal to N of A upon N of S. In the given example, getting a red ball is an event A. As there are 3 red balls, therefore N of A is equal to 3. As the number of balls is 4, therefore N of S is equal to 4. Therefore, probability of getting a red ball is probability of A is equal to N of A upon N of S is equal to 3 upon 4. Similarly, if getting green ball is an event B, then N of B is equal to 1. Therefore, probability of B is equal to N of B upon N of S is equal to 1 upon 4. Examples. 1. If 2 coins are tossed, find the probability of the following events. 1. Getting at least one head. 2. Getting no head. Note, at least one means one or more. At the most, one means one or none. Solution. 2 coins are tossed. Let S be the sample space. Therefore, S is equal to HH, HT, TH, TT. Therefore, N of S is equal to 4. 1. Let A be the event where at least one head turns up. Therefore, A is equal to HH, HT, TH. Therefore, N of A is equal to 3. Now, probability of A is equal to N of A upon N of S is equal to 3 upon 4. 2. Let B be the event where no head turns up. Therefore, B is equal to TT. Therefore, N of B is equal to 1. Now, probability of B is equal to N of B upon N of S is equal to 1 upon 4. Answer. Probability of A is equal to 3 upon 4 and probability of B is equal to 1 upon 4. 2. A card is drawn at random from a pack of well-shuffled 52 playing cards. Find the probability that the card drawn is 1. An ace, 2. A spade. Solution. There are 52 playing cards. Let S be the sample space. Therefore, n of S is equal to 52. 1. Let A be the event that the card drawn is an ace. There are 4 sets, namely heart, diamond, club and spade. Each set has 1 ace. Therefore, n of A is equal to 4. Probability of A is equal to n of A upon n of S is equal to 4 upon 52 is equal to 1 upon 13. 2. Let B be the event that the card drawn is a spade. There are 13 cards in the set of spade. One spade can be drawn out of 13 spade cards in 13 ways. N of B is equal to 13. Probability of B is equal to n of B upon n of S is equal to 13 upon 52 is equal to 1 upon 4. Answer. Probability of A is equal to 1 upon 13 and probability of B is equal to 1 upon 4. 3. If 2 dice are rolled simultaneously, find the probability of the following events. 1. The sum of the digits on the upper faces is at least 10. 2. The sum of the digits on the upper faces is 33. 3. The digit on the first dice is greater than the digit on the second dice. Solution. For there are 15 tickets in a box, each bearing one of the numbers from 1 to 15. One ticket is drawn at random from the box. Find the probability of event that the ticket drawn. 1 shows an even number. 2 shows a number which is a multiple of 5. Solution.